Okay guys, now I'm right here on pass by reference. Now, if you don't have a very good memory of doing the references, I go up here and look at references and pointers again, or in Canvas they are here. Pointer supplemental video is a good one. The basics explained. I'd watch these again, and because if you can't remember this very well, then this probably won't make much sense to you. Remember, when we put the and sign, it's pointing to the memory location. Okay, so now we're actually going to use those memory locations to do something useful. So we are going to name our function swap numbers, and what we're going to do is we're going to take the first number 10 and swap it with the number 20. So right now x is 10 and the second number y is 20. So before the swap you have 10, 20. Now we're going to look at what happens after the swap. So swap nums, this function right here, we're going to have the first number and the second number, the 10 and the 20, and when we run this function, what's going to happen is z, which is not in here, is going to now equal x. So what was in x, the 10, is now going to move over to the z slot. Okay, so now x is empty, because you got to remember it's a memory location. It can't hold more than one thing. I mean, it can hold a large portion of memory, but you can't put two different variables into one memory location. So x got moved to z. Okay, so now what's going to happen now is x is now going to equal y. So what is in y now moves over to x. Okay, now remember, the 10 is still in the z spot, so now z, or y, is now going to equal z. So see it as like a, maybe I can do it in paint or something, like a triangular deal. You have, let me delete that. You have two spots with data in them. You can't just swap them simultaneously from one to the other. If you have, let's just say, I'm just going to use like tally marks instead of trying to draw out numbers. A 1 here and a 2 here, and you need them to swap spots. You can't do that unless you have a third place. So you can move the 1 down, down to here. We'll just go ahead and do that. And that represents, where are we at? That represents the code. We are taking what is an x, the 10, and we are putting it into the z place. That's what we just did here. So now we have an empty space where we can move our y value to. So now this will move over to here. And now this is empty. Okay, so that represents x pulling, y's data. Y's data just moved to x. And now the last thing we're going to do is take x's data, which was in z, and we're going to put it into the y spot. So that moves up to here. So when it's all said and done, z is now an empty memory space again, but you were able to swap x and y that way. So that's what all this code right here is doing. Okay, let's see what else do we have. That's it for that. And back to lovely arrays. And again, that is something you may want to go back to week 6 and kind of look over your old projects and whatnot, and maybe look through the PowerPoint. That might ring a bell for some people, and make sure that you remember how the arrays work. Oh, wrong one. So what's happening here, here's your for loop. Your index in the array starts at 0. The first index in the array holds the value of 10. So here is your 10. And this goes on as long as the index is less than 5. So you got 0, 1, 2, 3, 4. So this entire array is going to end up here. So what's in the index of 0? The array needs to be incremented to the value of 1. The cout is my numbers in the index of 0. And don't forget, the increment doesn't work until the entire loop has passed. So now it's going to run and it's going to do it again. And so, you know, at this point, I would equal 1. And that's what gives you the 20. And if we run it right now, it'll probably just start at 20, unless I missed something. Yeah, it just starts at 20. And then that loop just keeps on running until I hits 4. And when it hits 5, that's it. It stops. It won't run again. So that is a function in an array. And let me see here. And here is where the function is actually being inserted, right here. But right now, it's almost it's almost pointless to do it this way if you're looking for a result like this. There's other reasons that you would put a function, you know, in an array, because don't forget, you can store a function elsewhere. So you know, if the function hasn't been used in 60 lines of codes, you can make your array, still reuse your function, and it's times like that when this would become handy, when you're actually reusing the function over and over and over again. But just make sure you understand the concept that you can use an array in combination with a function.